Okay, so question number 5. Give the full electron configuration for barium. Okay, so when we write out electron configuration, we want to follow the following rules. The first step is to divide your periodic table into different sections. So each section corresponds to a different orbital, S, P, D, and F. So it's important to know how to divide your periodic table this way, because sometimes on a test or like a quiz, they only give you just a blank, like a normal periodic table, and then you need to know what all the different sections or like where they would be. So for example, for our S block, it is the first two columns, including helium. So it's shown in light blue. So this is the S block. The P block is this whole like green rectangle. The D block is the middle transition metals, shown in orange. And then the F block are the last two rows, the lactanides and actinides in the periodic table. So that's the F block. And then step 2, so starting from hydrogen, you write the row number, then the block letter. And you kind of move from left to right across the periodic table until you get to your desired element. And then once we get to our D block, we're going to write the row number -1. And for the F block, it's going to be the row number -2. And I'm just going to add like a step 4. We typically order them from lowest to highest energy. So this basically is when you get to like your D block section. So if we were to go 4S and then 3D, sometimes it makes more sense to write your 3D and then your electrons before your 4S2 electrons, because realistically, your d orbitals that are half filled are more stable than a filled s orbital. So let me just write out our example, which I believe was barium. So for example, for barium, first let's locate it on the periodic table. So you can see it's right down here. So it has the atomic number 56, and we need to write the full electron configuration. So no shortcuts, or we don't write the shorthand configuration. Let's start from hydrogen and write the row number, which is 1, the block letter, which is S. And then to show how many electrons are in the orbital, we write it as a superscript. So 1s2 shows that there are 2 electrons in this 1s orbital. And then we go down to the next row, 2s2, And then we move across to 2p, which can house 6 electrons. And then 3s2. And then 3p6. Moving down, I'm going to write my 4s2 first. And then moving across to the d orbital, we have 3d10. So you kind of count out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all across the d orbital. 3d10. I don't even know if I can fit them all in this line. 4p6, 5s2, 4d10, and then 5p6. So barium is here. So then we just write 6s, and then up to the barium is just 6s2. Let me just try to fit it at the bottom on the right here. Should have given myself more room. But yeah, so this is the full electron configuration for barium. And if we wanted to write the shorthand configuration, basically all you need to do is find the noble gas that comes right before barium, which in this case would be xenon, and you just write it in square brackets. And then you continue on to write the rest of the electron configuration. So in this case, it would just be xenon 6s2. So it's much easier than writing the full electron configuration, but that's what the question asked for. So if we see what the junior tutor said, the atomic number of barium is 56. Yeah. And thus in this neutral atom, the number of electrons is also 56. With this, the corresponding electron configuration is 1s2, 2s2. Yep. 5p6, 6s2. Okay, so this solution is correct.